Hey, thank you. Hello, hello, hello. So, hi everybody. My name is Todor. It's an honor to be here. It's my first security conference, which I'm very excited about. Yeah. So we're going to be talking about some supply chain shenanigans with npm packages, NuGet packages, you name it. So first, let me just get a little grasp of the audience. Are there any software developers in the audience? And I mean that are writing code actively, not just know how to code? Okay, well, there are a few. So mostly me, okay. So yeah, who am I? My name is Todorov. I'm a senior software engineer at Payhawk. I'm a infosec junkie. I like doing security stuff. And I'm a clean code fanatic. I will fight with you to the death about that tab there or a new line. Yeah, I'm a DevOps evangelist. I'm helping teams transform into DevOps practices. Speaker, obviously. I'm a father of 3 boys. That's why I like to go to conferences a lot. And I'm a karaoke enthusiast. So if you want, we can go sing along afterwards. So without further ado, I don't have much time. I want to give you everything that I can say. So do you know what those are? I mean, if you're here and if you're a developer, some of you, they know what these are. So these are package managers. And what happens with package managers? They create supply chain attacks. So just in the last couple of years, it happened on numerous occasions with different types of exploits. And even the latest one was like a couple of days ago. A big one from NuGet, a loophole with some other things. And maybe this is the moment that you're asking yourself, okay, but why is all this happening? I mean, why the problem with package managers? Well, tell me how many times, especially the developers, you have seen this prompt, and especially that part here, and that part here. And usually this is something that many developers do. They just install packages and they don't look at any of the warnings. And they are there for a reason. Vulnerability scanners are there for a reason. npm and other package managers are doing their best in order to help you out with this, and you're not really looking at it. And I got a news flash for you. Package managers are evil. And they want to come for you with these types of attacks. So let's go through them. There are a couple of very common and major types of attacks that can be happening with package managers. So the first one is npm substitution or dependency confusion type of attack. So what does it mean is we have a public package repository, right? Namely npm registry. And because we are very security concerned, we have a private one as well, because we want to keep all of our packages scanned and cached and whatever, and for compliance reasons. And what usually happens, we create a proxy from the private one to the public one, because our developers still want to use public packages, right? Because, yeah, they give you some functionalities. And then we have a client in our ecosystem, and that client wants to use some package which is called console utils, for example, with version 1.5.3. But it's usually created like that, and it's usually added like that. And many times this is the default behavior of npm install, for example, or other package managers, that they are doing those wildcard things because they want to help you be up to date, which is generally not a bad thing. But what can happen here is we want to install a package, and our private package repository has that one because it has taken it from the public, which is the same version, 1.5.3. and the maintainer stopped maintaining that package. So there are no new versions. And some bad actor saw that, and they created a malicious one with another version. And they published it, because there are ways to do that. There are ways to create such thing. And when you try now to install the package, boom, you get the malicious one, and your client is infected. How can we prevent something like that? How can we fix it? So, first of all, don't use wildcards. Just use strict versions for all of your packages and update them when you need them. Don't just put them there and expect everything to happen automatically for you, because this is when you get caught. Use scope packages. Scope packages are something that is available in most package managers like npm or NuGet, where only user with some credentials can publish packages in the scoped namespace. Otherwise, if it's just console utils like the ones you saw before that, it's not the same thing. Don't ignore the warnings that I showed you. When you have vulnerability warnings, take care of them. It doesn't matter how stupid they seem to be. They might be false positives, but keep a sanitation level at the highest. Use checksum validation so that you can be sure that the package you're installing is the one that was found in GitHub. There are tools that can do that for you automatically. Commit your log files. This is something that a lot of developers are not doing for, in order to prevent some conflicts during commits. They don't commit their log packages, but this is what saves you from installing those wildcard packages. And also you can use some really good monitoring tools like MPQ that you can use for installing your npm packages. And it will do security insight while installing the package. This is a really cool one. I encourage you to go see it, to try it out. And just the other day, Microsoft also announced that from the next version of NuGet, they will have the same thing integrated into the platform. So we are getting there. People are thinking about those problems, and so on. So the next type of attack is called typo squatting. So typo squatting, we just heard a session about cloud squatting a little bit earlier. So it's kind of the same thing, something like that. This is what happened this year. Typo squatting campaign delivered a rootkit via npm package. And how that happened? So there is a very legitimate npm package called node hide console window, which is whatever package used a lot. And there was a new one that popped up in the registry, which was called node hide console windows. So you see the subtle difference? And when people are installing those packages, they usually do it by typing in the terminal, and writing Windows instead of window is quite a common mistake. Another thing, a while ago, this was also possible in npm, and those are two different packages. And there was a campaign of malicious packages that was pushed with just lower letters, because in the past, if you push a package with different casing, it will be it will not be the same like the lower one. And just recently, there was a cross-env malware campaign where npm found out that there were a lot of packages published by the same author, which very much look like other legit packages, and they all contained malware. One of those was cross-env. It was downloaded 675 times. It doesn't seem like a lot, but trust me, it is. The actual package has a hyphen between cross and env. How can we prevent something like that? So, first of all, package manager has to do their work, and they are. NPM, NuGet, Python, Maven, they're all doing their best in order to fit all of those new security rules and things like that. NPM, when they find a package like that, they mark it as a security holding package and you cannot install it anymore. They are doing due diligence, but it happens. I mean, it's not fast enough. You can still end up in a stage where you download such packages. The next thing, don't just write the name of the packages, copy paste it. It's this simple. When you want to install a new package, don't just write it in the terminal. Just copy the command from the npm site. It is there for exactly the same thing. Another thing, do not keep vulnerabilities in your code. Again, do not ignore the warnings. Go and fix them. That's essential. And another cool thing is when you're installing npm packages, and again, this works for NuGet packages as well, install it with ignore scripts, because I don't know if you're aware of, but you can put scripts that are being executed upon installation, and they are executed in the same scope as the installer. So if you're an admin and you install a script, install a package with that script, you can easily run a malicious script on your machine. So do it like that. And educate your developers. I mean, the most single thing that can help you out with all of those is to educate your developers on the security risks, because they don't want to hear about it, they don't know about it, they don't care about it. And that's a very common thing, but don't do it like, those really dry and boring security trainings that we do in the companies. Make it fun. Make CTFs locally. Make them experience how they can hack their system with npm packages. And the last attack that I want to call open source dependency injection. It's maybe the most, let's say, targeted one. There is a really amazing article in Medium by David Gilbertson. I have the sources. After the presentation, I will have the slides available to all of you so you can check it out. I urge you to read it. What he is talking about in his article of how he can be harvesting credit card numbers and passwords from your websites, it's very simple. First step, he creates a malicious package and hide it as if it is some nice package for coloring the console output. So who doesn't like nice colors, right? And you create a seemingly harmless one with some malware inside it. Step 2, you go and open a lot of pull requests in open source projects, in different ones. And you say, hey, I fixed that little bug you have there, and I also added some logging because it's cool. It's my package, it's open source, you can see it on GitHub, and people will love it because, yeah, and you're contributing to open source, right? And 3, profit. That's it. That was the whole thing that he mentioned in that article. There's a lot of ways that he described how he can circumvent your security measures against that. It's a really good one. Urge you to go check it. So how do we prevent something like that? Well, one thing that the author mentions in his article is that you can just go live here. Go in the woods, throw out your computer. That's it. That for sure that will help you out. Or maybe go here. But you will be yeah, the thing is, you won't be afraid of packages if you don't use any. That's one way to figure it out. But seriously, what you can do is, first, do not use packages on sensitive parts on your system. So when you have parts of your system that are dealing with passwords, credit cards, login information, you name it, don't use external packages. I know it's hard. I know your developers are going to cry about it, but just don't use them. Just use internally written code and nothing else. This is the only way to be completely safe. Another thing, know your dependencies and keep them up to date. I know I told you that you should keep a specific version and not the wildcard ones, but that doesn't mean you're not supposed to update your dependencies regularly, because this will prevent the vulnerabilities in your code that we saw earlier. And last but not least, zero trust policies for hosts that you are connecting to. So know every host that your platform or application is supposed to connect to, and do not allow anything outside of it. Try to skip all of those random marketing or data analytics endpoints that you have to cross somewhere. Don't do it. Some other things that you can do, you can use tools like deps.dev. It's sorry. So it's a really cool tool to understand your dependencies. It's a platform built by Google, and it can give you a really good insight on every package that you ask for. It will give you all of its history, dependencies, known vulnerabilities, when it popped up. You can easily see if something looks fishy in that package. You can also use other tools inside of your runtime. So there are those tools that can help you out with static analysis, with scanning container images for vulnerabilities and for common mistakes. All of those, I'm not going to go into details because I don't have the time, but again, there is a link below to an article with all of those tools explained. You can go and check them out and see for yourself. So, and I know that there will be people who will say, well, we don't use external dependencies in our code. We are aware of that. Oh, really? Okay. This is a white paper by Microsoft where they mention the Octoverse repo by GitHub that open source projects on average have 180 package dependencies. And again, it's not just packages. By show of hands, how many of you use Visual Studio Code? I guess almost everybody. It's a very popular one. Okay. I guess you know that Visual Studio Code is built with Electron, right? An Electron is nothing else than an NPM package. And that NPM package has 3 dependencies. And you would say, well, 3 dependencies are not that much. I'm sure I can keep track, and they are keeping track of them. Well, this is the graph of dependence of those 3 dependencies. This is how it looks like. And all the red ones are ones which are not updated to the latest version that can have vulnerability fixes. And this is from last week. And all of those packages in that dependency tree are maintained in total of 98 maintainers. So those are all the people that have written code inside your Visual Studio Code. And tell me, do you trust them? Do you trust I am Evil Rabbit? Because we know we don't trust people on the internet, right? Well, you don't have external dependencies, yeah, but Visual Studio Code with Electron is there. And it's not only Visual Studio Code. A lot of applications are built with Electron. A lot of applications you are currently using that your developers and users are using. And I Am Evil Rabbit is in all of those. But take a chill pill. I know it sounds really scary, but it's not scarier than anything else in the internet. So how can we prevent? Let's do a little summary here of what we talked about. So what we can do, know your dependencies. Don't just install whatever you like. Don't let your developers install whatever they like. Make them audit the things that they are installing. Use less if possible. Again, do not use packages on sensitive part of your application. Use a lot of tooling. There are tons of tools for monitoring, for scanning, for insights, for preparation, for whatever. Use them and incorporate them in your pipelines, incorporate them in your images, in your runtime scanners. And again, last but not least, educate the developers. Tell them what it means to have a vulnerability in the code and show them how to fix it. And with that, I want to thank you for being here. You can find me in all of those places. I will be here until the end of the day and tomorrow as well. I am free for chat, and thank you. That's it.
Woo. Thank you. So we actually have time for 3 or 4 questions. So yeah, lots of questions here. Let's start from the back this time. Yeah.
Hi Toshko, thanks for the talk. I have a question about the first example that you showed about the console utils. How easy is it for an attacker to publish a new version of a package if the package is owned by another person, even if it's not maintained?
Sorry, I didn't get it. Can you repeat it?
Yeah, if I'm an attacker and I want to publish a new version to this console utils package, which I don't own, how easy it is to do it?
Well, it is kind of easy. Some of those, I mean, you can, if the package is dead, I think you can easily like take over, but I'm not 100% sure how you can do that.
Okay, thanks.
Hi.
Hi.
My question is around transitive dependencies. So especially in NPM, each dependency you get is going to bring 10, 50, 100 more dependencies. How do you manage those? Because it's easy to find and update the direct dependencies, but the transitive ones are a bit more complicated.
Yeah. Well, there is, as far as I know, there isn't a real way to fix that. I usually would just drop a package that has a lot of vulnerability and old transient dependencies and use another one. Because at the end of the day, you're kind of stuck with what you have there, unfortunately.
Hello, and thank you for the presentation. It's my very first conference as well, cybersecurity one. So my question is again to these transitive dependencies, because unfortunately, usually the vulnerabilities are found very deep in the tree. And there is no even patch available for this. How do you handle this? Do you use any tools to analyze if the vulnerable part of this code is actually used by your application?
Yes, some of the scanning tools that I mentioned, I don't remember the name, can do that for you. It has some of those are like scanning for hot paths and paths where that vulnerability is hitting, but that's mainly based on static analysis, which I don't always trust personally, because yeah, it can happen again like transitively. Yeah.
Okay, 1 or 2 more questions.
Why does npm actually allow to run scripts on a developer machine?
Sorry, why?
Why does npm allows to run scripts on a developer machine?
Well, for reasons, because usually those scripts, the idea behind them is to set up some stuff around the npm package that is needed, like create some directories, populate some config file or whatever, and it is what it is. Because it can be really useful, and there are very good use cases where those scripts work very well. I have done such scripts in the NuGet space, which can help you exactly set up environment when installing a NuGet package with some stuff around it. For example, you can populate some code inside the repository, like unpack it, which can be used as a template by the developer for whatever usage of the npm package itself or the NuGet package. So that you can do with scripts, and yeah. I would ask why it is allowed on production environments, but yeah, for the same reason.
And last question. Do we have a last question? Yes, we do.
Awesome presentation, because even like a month ago we had the discussion with the developers about it. In our case, it's also like Ruby, Python, everybody is suffering from this. But my question is, in the last year we brought topics, shadow code, this is shadow code. Then we had shadow API, that's also a thing. And now we're also talking, of course, about the bigger thing, shadow IT. And my question is, what's next? Like, I'm already overwhelmed, to be honest.
Living in the woods would be next.
Yeah, thank you.